Assalamu alaikum, grade 9 computer science students. We will start lesson number 15. This lesson is about data storage. In this lesson, we will discuss about characters and sound. How characters and sounds are stored inside the computer. Let's start. As you know that computer can process only binary numbers, that is zeros and ones. So what it means, you store anything on the computer, it will be stored in the form of zeros and ones. Computer can store different types of data like text, numbers, symbols, pictures and sound in binary form. So it means whatever you save on the computer, even if it is something, a written document, only numbers, pictures and sound, it will be stored in zeros and ones. And before this we have discussed that why computer can uh, understand only binary, because inside a computer the internal circuitry is combination of electronic circuits, and each circuit is corresponding to zeros and ones. There are two systems that are commonly used for characters including text, numbers and symbols. We have ASCII, American Standard Code for Information Interchange, and Unicode systems. So if we are using ASCII, the ASCII is using only 8 bits. So 8-bit means, let me take the pen to explain it a little bit. Okay, so 8-bit means 2 power 8, and 2 power 8 is 256 characters. So if we have 8 bits, example, this is 1, 2, 3, 4, 5, 6, 7 and 8, for example. So there can be 256 possible combinations of these 8 bits, and as a result we can represent 256 characters. So it is suitable for English language, but if you want to have characters for the other languages, then it's not enough. 256 are not enough. ASCII code for each characters on the keyboard, whatever key you press, it will be converted into a binary number, and this binary number is of 8 bits. For example, the letter A has a decimal value 97, and decimal in binary is equal to this code. Likewise, B is 98 in decimal, and the equivalent in binary is this code. Likewise for C is 99, and the binary code is this one. So we have 256 different characters that we can represent with the ASCII code. So if we count the capital alphabets and the small alphabets and some other symbols, so we can represent 256 with ASCII code. We have another system that is used to represent the characters inside the computer, but this is called Unicode. Unicode uses 2 bytes, that is 16 bits. So capital letters and small case letters have individual binary code as 2 numbers and punctuation, and we can represent the alphabets from the other languages as well. So if we have a UTF 8, so we have 8 bits, but for 16 we have 16, and we have possibly a UTF for 32 bits. So if we are using 32 bits, so this is how we can represent it in binary. Okay, global companies like Facebook and Google will not use ASCII because you can represent only 128 characters, but with Unicode you can represent 1.1 million characters, and that in all languages. So you can have codes for almost alphabets from all languages. How we represent sound inside the computer. So how you enter or input sound into the computer. Normally you have a microphone and you speak to the microphone, and then your voice is recorded on the computer. But inside the computer, the sound is not safe like the sound is like analog, but inside the computer this is represented as digital. As you know, digital means that we have 0 and 1, and then we have 2, and then we have 3 and 4 and 5. So we do not have something in between. Now if we want to store this inside the computer, we need to sample it. I will be explaining the sample in a moment. So we need to take sample at 1, for example, then at 2, then at 3, here is 3, and here is 4, for example, and the 5 is here, things like it. So analog means continuous, like this, there is no jumps, smooth, right? It's analog. But inside the computer we can represent digital, and for this digital representation the microphone converts from analog to digital, and this is called analog to digital converter. So we have the original one, the original sound wave. You can see it in the purple color, and in the green one you have the sample. It's like I told you, can sample it 1, then here is an example 2, 3, 4, here's 5, 6, 7, 8, 9, and 10. So if you are using digital, then the green one, but for analog we have the purple one. Now if you have sample at each second, example, so you have a line like this, but what if we have a sample closer than this one? Now you may be wondering what we mean by sample. So let's suppose we want to test the water in some area, if it is fit for drinking or not. So what we will do is we will take some water, take it to laboratory, and we can test it there. Likewise we take sample for the blood for some test. Likewise, if you want to find the interest of people in some area, example any product, the company is worried about why our product is not selling in that particular area of the city, and for this purpose the company do a survey, and the survey they ask different questions from the people. Okay, so why you don't buy our product? So maybe some people don't know about the product, some people know about the product but they cannot afford it, and maybe some people even afford it but they don't like the color of the product or whatever it is. So if you are asking many people, you will get more closer uh, result. But if you are asking only one or two people, then it means your result is not that perfect. If you ask 10 people instead of 2, you get more better result. But if you are asking 20 people, then the result is more better. So what it means is the sound quality will improve if we sample at much closer space. But when you are taking more samples, it means the quality is better, but then you need more storage space. Okay, so what it means is if we want to increase the quality, it will have more space. It will take more space. Now if we convert this, if we have more space and we convert it back to analog, it will be almost the same quality. Now the frequency at which the samples are taken is called sample rate, and it is measured in hertz. 1 hertz means 1 sample per second. 1 hertz means 1 sample per second. So 1 sample per second is like this. So 1 here, 1 here, 1 here. Okay. But the CD quality audio is sample 44,100 or 48,000 kilohertz. So it means there are a lot of samples taken per second if you want to get the CD quality audio or sound. Home task for you: write notes about the characters and sound data storage, how it is stored in the computer. You have to write about it. We will continue about the pictures storage in computer, how the pictures are stored in the computer in the next lesson. If you have any question regarding this lesson or the previous lesson, you can send your queries on WhatsApp. Thank you.